So, hi guys, welcome back. So, we're still on module number 3, equilibrium. Okay, so observe that there are only three independent equations of equilibrium. We have the summation of forces along the x-axis, which is 0, summation of forces along the y-axis is equivalent to 0, and summation of moment is equivalent to 0. If equations that are not independent are obtained, it may be because the selected axis or moment centers do not permit the one unknown to be found independently of the other two. It is best to choose other axes or moment centers until the three independent equations are obtained. In applying moment summations, it is best to select the moment centers at the intersection of two unknowns, thereby eliminating these unknowns from the moment summation. So here, what we're going to do is further discuss planar equilibrium, wherein we're going to maximize the use of our moment equation, summation of moment. Okay, so we will tackle that in examples 1, another examples 1, 2.
Okay, so we have here problem number 1. Determine the forces P, F, and T to keep the triangular frame ABC. So this is ABC triangular frame in equilibrium. Okay, the problem here is if we're going to look from our given, we have three unknowns. Okay, if we're going to use the summation of forces vertical, we will be having two unknowns. Summation of forces along the y-axis, horizontal, we will be having three unknowns. Okay, so two equations, one unknown. And if we are going to have our moment with respect to point B, we can solve it right away, by the way. But what I'm going to show you is another method, okay? Because if we are going to use that, we can have our moment at point B, then we can solve for for force T. Then if we do so, we can use summation of forces vertical, summation of forces horizontal to equations to unknowns. Okay? So but what I'm going to show you is another way of solving it. Okay? As what stated in our module. So what we're going to do is to extend the line of action of our forces. So that is point B. I am going to extend it in that way. Then the line of action of point T would also be extended. Okay? And they will be having an intersection or point of tangency. Likewise, with force F, I am also going to extend it, the line of action, and force T, I will also be extending it. Then again, I'll be having here a point of uh, intersection. By principle of transmissibility, I can say, let's say that this is point D and this is point E, okay? But by principle of transmissibility, I can say that this would be my Py and this would be my P of X. Likewise, this would be my F of Y and this here would be my F of X. Okay, but before we proceed any further, let us first solve the distance. What would be the distance from this point to this point? And what would also be the distance from this point up to this point? Okay, so using the slope, we have here vertical of 3. So let's say from point C to point D, we have the slope here 3:1, 1 for the vertical, 3 for the horizontal, is equivalent to, we have the vertical here of 8 feet is to the distance C to D. Okay, therefore cross multiplying, CD is equivalent to 8 times 3, and that is 24 feet. Then distance AD is equivalent to CD, CD, 24 minus 12, and that is equivalent to 12 feet. So the distance here is 12 feet. Likewise, we can solve for the distance here. So we have there a slope of 2:3 is equivalent to the vertical of 8 and the horizontal of distance CE. Okay, cross multiply. CE is equivalent to 8 times 3 divided by 2, and that is equivalent to 12 feet as well. Okay, so we can now start solving for our unknown. So let's start with t. So if I'm going to solve t, I'll be having my moment with respect to point B. Because if I'll be having my moment at E, point C is concurrent with point E. If I'm going to have my moment at D, it is point T is also concurrent with point D. Likewise with point P. But I can solve point F. But let's start first with force T. So summation of moment with respect to B is equivalent to 0. All forces that are going to rotate clockwise would be positive. So what are the forces that are going to rotate? So we have here 3,600 rotating in a clockwise manner, so that would be positive. So 3,600 times a lever arm of 12. So times 12. Next, 1,200 is also concurrent. Okay, therefore we can simply cancel out 1,200. Likewise with B and F, they are concurrent with point B. Okay, then we are left with point T. Take note, point T, it is going to rotate in a counterclockwise manner. Therefore, it is minus T times a lever arm of 8. And that is equivalent to 0. So we have here 3,600 times 12 minus alpha x times 8 is equivalent to 0. Force T is equivalent to 5,400 pounds. Okay. Next, we have our moment at point D. Okay. So summation of moment at point D is equivalent to 0. All forces that are going to rotate at point D in a clockwise manner should be positive. Okay. So what are the forces that are going to rotate? So we have here the 3,600 pounds. The 3,600 pounds will be rotating in a counterclockwise. So that is negative 3,600 times a lever arm of 12. Next, we have 1,200. 1,200 would be rotating in a clockwise manner. So that is positive. So plus 1,200 times a lever arm of, take note, from C to CD, we have 24 feet. So times 24. Okay. Here, force T will cancel out because it is concurrent with D. Likewise, with force P, it is concurrent with D. Okay? So we are left with Fy and Fx. But f of x is concurrent with point D. Therefore, we are only left with Fy. Fy is equivalent to the vertical component of the slope divided by the hypotenuse of the slope. And the hypotenuse is the square root of 13. And that is F. So Fy is also rotating in a clockwise manner. So that is positive. Fy times the vertical component of the slope, which is 2 over the hypotenuse of the square root of 13, is times the lever arm. times the lever arm of 12, 12, 12, and that is 36 is equivalent to 0. And we have 721 pounds. Fy is 721.11 pounds. Okay, we can now solve for the P. But take note, pwede nyo rin ilagay itong f of x, f of y at this point. So it would be, if rather than fy times 2 over the square root of 13 times 36, magiging fy times 2 over 13 times, ang lever arm natin here would be 24. But we're going to include f of x. So we will have another plus f of x times the horizontal component of 3 over the square root of 13 times a lever arm of 8. Okay, I repeat, you can put the f of x and f of y at this point, but if you're going to place it here, we will include fx, and they should generate the same answer. Okay, so next would be the P. So in doing so, we can have our moment at point E. So summation of moment at point E is equivalent to 0. All forces rotating in a clockwise manner should be positive. So what are those forces? So we have 3,600. It is rotating clockwise times a lever arm of 12, 24. Next, we have 1,200 rotating counterclockwise. So minus 1,200 times a lever arm of 12. Next, take note, force F and force T are concurrent with point E. Therefore, we can simply cancel them out. Okay? So, we are left with P horizontal and P vertical. Okay? So, or, pwede rin na nandito si PY at saka si PX, so that we can cancel out PX because it is concurrent with point E. So, we will only have PY rotating. Okay? So, I repeat, pwedeng dito, nandito si PY, nandito si PX. Dalawa silang magro-rotate. You have the PY counterclockwise. PX would also be counterclockwise. But it would be best if we place it here so that we can cancel out PX because it is concurrent with point E. Okay, since I already placed here PX and PY, I am going to use this point. Okay, so by the way, this is by the principle of transmissibility. So we have PX cancel out PY, and it is rotating counterclockwise, so that is negative. PY times a lever arm of 12, 24, 36. And that is equivalent to 0. Okay, so we have 3,600 times 24 minus 1,200 times 12 minus alpha x times 36 is equivalent to 0. And therefore, wait. We forgot the slope. The vertical. Sorry, we forgot the vertical component of the slope. So minus py times the vertical component of the slope, which is 1, over the square root of the hypotenuse, which is 3 squared plus 1 squared. Okay? Times the distance or lever arm, and that is 36 is equivalent to 0. So we have 3,600 times 24 minus 1,200 times 12 minus alpha x times 36 divided by the square root of 3 squared plus 1 squared, and that is equivalent to 0. And the value of P therefore is equivalent to 6,324.15 56 pounds. Okay? What if, itatry ko siya dito. Now, to prove you that they should generate the same answer, we will try it here. Okay? Same. So, we have here or. Okay? Summation of moment with respect to E is equivalent to 0. All forces rotating in a clockwise manner are to be positive. So, we have here, I'm going to place Py, and I am going to place Px here. Okay, so same 3,600 clockwise direction. So we have 3,600 times a lever arm of 24. Then we have 1,200 rotating in a counterclockwise. So minus 1,200 times 12. Next, we have Py. Py is rotating in a counterclockwise. So minus Py times the vertical component of the slope, which is 1. So times 1 over the square root of 10. Okay, because 3 squared plus 1 squared is 10. So that is the square root of 10. Times a lever arm of, what's the lever arm here? That is 12. Times 12. Next, we have Px. Px is also rotating in a counterclockwise. So minus P of x times the horizontal component of 3 over the square root of 10 times a lever arm of 8. And that is equivalent to 0. So solving for the value of P, we should remove the Py because it is already in terms of P. Okay? P therefore is equivalent to 1 over the square root of 10. No. 10 times 12 minus 3 the square root of 10 times 8 equals 0. So they are the same. 6,324.56 pounds. Okay, so we have here problem number 2. The weight of the trapezoidal block is 7,200 pounds, acting where shown, and it is shown in the figure. The ground reaction varies uniformly with an intensity of PA on this side and PB on this side. Of course, since this is a trapezoidal load or uniformly varying load, we will expect that the reaction would also be the same. Okay, so we are to determine the value of PA and PB. So what we're going to do here to make it a lot easier is to divide it into two triangles. Okay, so because I need to solve for the value of PB and PA, so I need the value of PB and I need the value of PA. So I'll be dividing it into two triangles. Okay, so we have here the triangle 1 and we have here triangle 2. Okay, and the resultant of this, the resultant of area 1 or pressure 1, as we all know, will be applied 1/3 from the base. The total distance from this point to this point is 12 feet. Okay, so 1/3 of 4 is one-third of 12 is 4. Therefore, we know that reaction, so we have here the resultant A, let's say resultant 1 is acting 4 feet from A. Now we have triangle 2 or area 2, and again it is a triangle. Therefore, the resultant of triangle 2 is also acting 1/3 from the base. This time the base is at point B, and 1/3 of 12 is 4 feet. So this is also 4 feet. So 4 feet plus 4 feet minus 12 feet, the distance between reaction 1 and reaction 2 is also 4 feet. Okay? So solving for R1, we have reaction 1 is equivalent to area 1. And what is area 1? It is base of 12 times the height of PB times 0.5 because it is a triangle. So that would be 1/2 times the base of 12 times the height of PB. No, that's PA. PA. So simplifying, it is 6 PA. Okay? Next, we have R2. What is R2? R2 is simply the area 2. And what is area 2? We have here, since this is a triangle, we have 1/2 times the base of 12 times a height of PB. So simplifying, it is 6 PB. Okay? So solving for PB, we have, or PA, we are going to have our moment with respect to any of these two. Because if I'll be having my moment at R1, R1 will cancel out. I can solve for R2. If I am going to have my moment at R2, R2 will cancel out. I can solve for R1. Okay? So, summation of moment at, let's say, R1 is equivalent to 0. All forces rotating in a clockwise manner should be positive. Okay? So, this is R1 and this is R2. So, I'll be having my moment here. The forces that are going to rotate would be 7,200 in R2. So, we have 7,200 times a lever arm of 5 feet from A, 4 feet from A. So 5 minus 4 is 1 feet. The distance between 7,200 pounds and R1 is 1 feet. So times 1. Okay. Next would be R2. R2 rotating with respect to R1. So we have PB and that is 6 PB. So minus 6 PB times a lever arm of the distance between them is 4 feet. And that is equivalent to 0. So solving, we have 7,200 times 1 minus 6 times 4 times alpha x is equivalent to 0. Shift solve. And that is equivalent to 300 pounds per feet. Okay. Next would be summation of moment with respect to R2 is equivalent to 0. All forces rotating clockwise are to be positive. So we have here 7,200 rotating naman in a counterclockwise. So negative 7,200 times a lever arm of. So from B. Let's have it from point B. From point B, it is 7 feet. And from point B, R2 is 4. So 7 minus 4 is equivalent to 3. Tama ba? Yes. 7 minus 4. Yes. So that is 3. 7 minus 4 is 3. Then we have here R1. R1 and R1 is 6PA. R1 this time is positive. So 6PA times a lever arm of 4 feet. And that is equivalent to 0. So negative 7,200 times 3 plus alpha x times 6 times 4 is equivalent to 0. PA is equivalent to 600 pound per feet. And that is the final answer. Okay, so we have here problem number 3, a pulley of 1 feet radius. So this is the pulley supporting a load of 500 pounds. So this is the 500 pound is mounted at point B. Okay, at a horizontal beam shown in the figure. So this is our beam, and it is supporting our pulley. If the beam weighs 200 pounds, the beam is 200 pounds, while the pulley is 500 pounds, 50 pound rather. Find the hinge force at point C. So we need to determine the hinge force at point C. It is not simply the reaction. Okay, so what we're going to do is we're going to transfer the loading, this load, to our pulley, and the load of the pulley to our beam. Then from there, we're going to solve for the hinge at force C. Okay, so let's draw our free body diagram. So this is our free body diagram for our pulley. Okay, so take note that for our pulley, we have a 50-pound force. Okay, so we have there a 50-pound force. Then we also have here, take note that here we have a 500 pound force also, which is pulling. And at the same time, we also have a 500-pound force, which is pulling downward. Okay, so we need to translate that into this system. Okay, so we also have here the B vertical. This is the B vertical, while this is the B horizontal. Okay, and this is the pulley. We have here another this is the 500, and we also have here another 500 pounds. Okay, so from there we can now solve using the equation of equilibrium. So summation of forces, I think it would be a bit better if we use the summation of forces along the horizontal. So we can solve this. Yeah, we only have two unknowns lang pala. Summation of forces horizontal is equivalent to 0. All forces that are pointing towards right should be positive. Okay, so the slope of this one is 3 vertical for horizontal, therefore the hypotenuse is 5. So for the horizontal, we have B horizontal rather. So B horizontal minus 500 times the horizontal component of the slope, which is 4 over the hypotenuse of 5, is equivalent to 0. Therefore, B horizontal is equivalent to 500 times 4 divided by 5, and that is 400. Okay, next for the B vertical, summation of forces along the vertical axis equals 0. All forces that are pointing upward should be positive. So what are those forces? So we have 500. We have here 500, and it is pointing upward, times the vertical component of the slope, which is 3 over the hypotenuse of 5, minus 50 pointing downwards, minus 500, it is also pointing downwards, plus B vertical because it is pointing upwards. B vertical is equivalent to 250 pounds. And it is correct, pointing upwards. Okay, so what we're going to do now is to transfer it to our beam. Okay, so if on the hinge it is pointing upward, on the pulley rather, if it is on the pulley, if on the pulley it is pointing upwards, if we are to transfer it on the beam, it should be on the opposite side. If on the pulley it is the B horizontal is pointing to the right, on the beam it would be pointing to the left because it is in equilibrium. That is to cancel out the force. Okay, so downward, upward, that will cancel out. To the right, to the left, that will cancel out. Okay, so we have here B vertical as 250, and we have here B horizontal as 400. Okay, so we can now solve for C. We don't need actually the reaction of A. So what we're going to do is I'll be having my moment at A. So summation of moment with respect to A is equivalent to 0. All forces that are rotating clockwise should be positive. So what are those? We have 250. So 250 times a lever arm of 3 feet. Then we have here my assumed direction for the reaction. Take note, our support here is a pin, so there will be two reaction. Okay, so my assumed direction for C vertical is upward, while C horizontal is to the right. Okay, so C vertical is pointing upward, so it would rotate in a counterclockwise, so that would be negative, minus C vertical times a lever arm of 5 feet. 400 is concurrent. Okay, so it is concurrent, therefore it will not be rotating at point A. So we only have 250 and CV. So we have here, and that is equivalent to 0. So 250 times 3 minus alpha x times 5 is equivalent to 150. C vertical is equivalent to 150 pounds. Next, for the C horizontal, summation of forces horizontal is equivalent to 0. All forces that are pointing to the right should be positive. So I have here negative 400 plus C horizontal equals 0. Transpose this to the other side of the equation to make it positive. C horizontal therefore is equivalent to 400 pounds. Okay, so CV is equivalent to 150, and C horizontal is equivalent to 400 pounds. Okay, so for the force at hinge C, it is simply the square root of the squared property, the summation of the squared property. So we have C vertical squared plus C horizontal squared, and that is equivalent to the square root of 150 squared plus 400 squared, and that is equivalent to 427 point, wait, we forgot to include the weight of the beam, and the weight of the beam is acting at the center. So we have here the weight of the beam as 200. Okay, since that would be the case, this is incorrect. So going back to our moment with respect to A, summation of moment with respect to A, you have 250 times a lever arm of 3. Then you have C vertical counterclockwise, lever arm of 5. Again, we have 200 rotating clockwise, so that is plus. So plus 200 times a lever arm of 2.5, and that is equivalent to 0. So 250 times 3 minus alpha x times 5 plus 200 times 2.5 is equivalent to 0, and that is 250 pounds. Okay, so this is 250 pounds. So the square root of 250 squared plus 400 squared is equivalent to 471.70 pounds. Okay, and that is our hinge force at C. Okay, now for the angle, theta x is equivalent to arctangent of C vertical over C horizontal. So tangent, if we are to draw that, this would be our resultant actually. Why? Because our CV is upward, our CH is to the right. So therefore, our resultant would look like this. And this is our theta x. So opposite, that is CV over adjacent. Okay? So theta x is equivalent to arc tangent of what is C vertical? 250 divided by 400. Theta x therefore is equivalent to 32.01 degrees. Okay, so hinge force at C is 32 degrees from the positive x-axis. Okay, or 32 degrees to the right. Okay, so we have here problem number 12. 4 rather. A 12 feet bar of negligible weight rests on a horizontal position on a smooth inclines. So this is the 12 feet bar and it is resting on a smooth surface. So since this is a smooth surface, we will only be having one reaction, and that is perpendicular to the normal to the point of contact. Okay. Compute the distance at distance x at which the load T or the 100 or the load T 100 pounds is to be placed in order to keep this bar horizontal. Okay? We can solve this problem using the three equations of equilibrium, but there is a shorter way of solving this by using the Lomy's theorem. Okay, so like what I've said a while ago, since this is a smooth surface, we will be having one reaction only per contact surface, and that is normal to the point of contact. Okay, so this is NA and this is NB, and we need to solve for the value of x. Okay, so we have here, by redrawing that, we need to redraw our free body diagram. We have here, this is NA, this is NB, then we have here two forces. We have here P, which is equivalent to 200, and we have here T. Okay, so and the T is equivalent to 100. Okay, so the angle here is 45 degrees, therefore the angle also here is 45 degrees. Okay, so if I am to draw a plane there, the angle here is 45 degrees, complementary, therefore the angle also here is 45 degrees. Okay, no, this is not, yeah, okay, so we have here 45 degrees. Okay, the angle here is 30 degrees, therefore the angle also here is 30 degrees. Therefore the angle here is 30 degrees. The interior angle of a triangle is 180 degrees. So 180 minus 30 minus 45 is equivalent to 105 degrees. Okay, now we need to solve for NA. Why are we going to solve for NA? Because if we have the value of NA already, we can have our moment here. We no longer need to solve for NB. And since that will be the case, we can now solve for the value of x. Okay? So, since this is the missing, since we have, this is the missing, I have two angles and I have one side. I am given with two angles. I can use the sine law to solve it. easier. So sine law. So sine 45, so this is NA over sine 45 is equivalent to 200 plus 100 over sine 105. Okay, so cross multiply. NA is equivalent to 300 sine 45 over sine 105. NA therefore is equivalent to 219.62 pounds. Okay, so since I already have NA, I can now have my moment with respect to B. So summation of moment with respect to B, all forces that are rotating clockwise will be positive. Okay, so what are those forces? We have, let's start with force P. Force P will be rotating in a counterclockwise, therefore it is negative. Negative 200 times a lever arm of. So 12 minus 3, that is equivalent to 9 times a lever arm of 9. Then we have T would also be rotating in a counterclockwise, so minus T times a lever arm of X. Next we have NA, but NA is inclined, so we need to get NA Y. So in doing so, it would be a cosine function. And it is rotating in a clockwise, therefore it is positive. So plus cosine 30 is equivalent to the adjacent NAY over hypotenuse. Cross multiply the hypotenuse, and that is 200, hindi kasha, lagyan dito na lang natin, 219.62, and that is equivalent to 0. Okay? We forgot to substitute the value of T. So, negative 200 times 9 minus the value of T, which is 100, 100x plus 219.62 cosine 30 is equivalent to that is, oh wait, that's too big. We have an error somewhere. We forgot the lever arm of this one. So we forgot the lever arm, which is 12. So times 12 is equivalent to 0. Okay, so X therefore is equivalent to 4.82 feet from B. Okay. Okay, so we have here problem number 5. A Fink truss is supported by a hinge at A and by rollers on 1 and 2. Alright, by a rollers on a 1 to 2 slope at B. Okay, so 1 is to 2. The bracing bars are normal to the inclined members of their midpoints. The wind loads are perpendicular to AC. So this is a 90-degree angle. Okay. Then determine the horizontal and the vertical components of the reactions at A and B. Okay, so we need to determine the vertical and the horizontal components. Okay. So we need to determine A vertical, A horizontal, B vertical, then B horizontal. Okay, so how are we going to do that? So first we need to determine these distances. What is the distance here, what is the distance here, and what is the distance here. And by doing so, we can see from the picture that it is symmetrical. Okay, so it is a symmetrical one. So here it is 12, right? So this is 12. So since that is symmetrical, we can say that the distance from the center to point A is equivalent to 72 divided by 2. So that is 36. So the slope here is 12 divided by 36, 1:3. 1 vertical, 3 horizontal. Since the loading here are perpendicular with respect to AC, then we will be having here 1 horizontal, 3 vertical. They will exchange. Okay? So yan yung magiging slope natin. So 3 squared plus 1 squared, that is 10, and therefore the hypotenuse is the square root of 10. Okay? So how are we going to do that? Since we already have our slope here, we can solve for an angle. Let's say this is angle theta. We can solve for angle theta. So angle theta is equivalent to the tangent. Tangent theta is equivalent to opposite over hypotenuse. And the hypotenuse is adjacent or opposite over adjacent, 3. So theta is equivalent to arctan of 1/3. Therefore, that is equivalent to 18 degrees. Okay, so 18.43 degrees. Since I already know the distance here from point A to the center, I can now solve the distance A to C. Okay? Using the slope. Or pwede rin naman yung angle, but it would be more accurate if we're going to use the slope since we can avoid decimals. Okay? So, the slope is 1:3 is equivalent to the vertical is to 12 while no 1 is to vertical over the hypotenuse of 10, but we can make do with this. So na-start na natin, sige tuloy natin. We have we do not have an unknown. No, this is erroneous. Okay, so we have 1 vertical is to the square root of 10 is equivalent to the vertical, which is 12, over the hypotenuse AC. Okay, so cross multiply, AC is equivalent to 1 over the square root of 10 is equivalent to 12 over alpha x. Okay, so it is 37.95 meters. So from point A to point C, that is 37.95. Okay, so from point A up to this point, sabihin natin that is A, B, C, D. Let's say that is point D. Okay, so A to D is equivalent to 37.95 over 2. Okay, so we have the answer here, 37.95 divided by 2. 18.90 18.975. Let's use 18.975. 18.975 feet. Yes, that is in feet. No, it's not in meter. We have feet. Okay? So, since we already have that, take note, meron na tayo dito. The distance here is 18.975. It is not feet, it is not meter, it is in feet. Okay? So, yeah. Then from there, pwede na natin i-solve itong distance na to. From this point to this point. By a right triangle. So, redrawing that, if we are to redraw that, it would look like this. We have here an angle of 18.43 and we have here a distance of 18.975 and we are looking for this distance. Let's say, base it from our module, this is abbreviated as M. And this is a right triangle. Okay? So, what function are we going to use? It is cosine. Adjacent over hypotenuse. Okay? So, cosine 18.43 degrees is equivalent to 18.975 over M. Cross multiply, M is equivalent to 18.975 divided by cosine 18.43, and that is equivalent to 20. So we have 20 feet. So yeah, we can now solve for, let's say, we will have our moment at A. We can solve for B. Summation of moment with respect to A is equivalent to 0. All forces rotating clockwise should be positive. Okay, so this is A. We will have our moment here. So what are the forces that are going to rotate? So take note, this is 20 feet. Since this is symmetrical, this is also 20 feet. So 72 minus 20 minus 20, that is 32. So the distance here is 32 feet. Okay. So yeah, we can now have our moment. Summation of moment. What are the forces? First, we have 3,160 rotating in a clockwise manner. So 3,160 times a lever arm of 18.976. Take note, this is a perpendicular distance, so that is the lever arm. Next, we have 1,500 rotating in a clockwise direction, so that is again positive. So plus 1,580 times a lever arm of perpendicular distance, which is 37.95. Next, we have the 8,400. 8,400, that is a perpendicular distance. So, rotating in a clockwise manner. So, again, that is plus. So, plus 8,400 times a lever arm of 20 plus 18,000. Again, it is rotating in a clockwise manner. So, plus times 52 feet. Okay. Next, we have here, take note that the reaction is acting on the pin. Okay? Or the roller. Nandito siya. So, this is B vertical, and this is B horizontal. So B horizontal is concurrent with A, so we can cancel that out. We are left with B vertical, and it is rotating in a counterclockwise manner. Okay, it is rotating in a counterclockwise manner. So therefore, we will be having negative B vertical times a lever arm of 72. Did we forget something? No. And that is equivalent to 0. So we have here 3160 times 18.976 plus 1580 times 37.95 plus 84 times 20 plus 18,000 times 52 minus alpha x times 72 is equivalent to 0. And that is equivalent to 16,000. B vertical is equivalent to 16,998.96. So if I'm not mistaken, from your module, it is 70,000. So it is almost equal to 17,000 pounds. And our assumption is correct. It is pointing upwards. Okay. So since I already have my B vertical, I'll just have the summation of forces vertical. So summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So my assumption here, A vertical is pointing upwards. Okay? So I have A vertical minus 1,580 times the vertical component, which is 3. Take note, the slope is 3:1. So 3 over the square root of 10 minus 3,160 times the vertical component of the slope, which is 3 over the hypotenuse of 10 minus 1,580 times the vertical component of the slope, which is 3 over the hypotenuse of 10, and minus 8,400 minus 18,000 plus the B vertical plus 16,998.96, and that is equivalent to 0. A vertical is equivalent to, we have and that is equivalent to 15,652.86 pounds, and that is A vertical. Okay, the next thing that we need to do is to solve for A horizontal here, and B horizontal. Sir, from your previous discussion, you said that a roller has only one reaction. Okay, that is true. But take note, our roller support here, roller has only one support. But take note, our roller here is inclined. Therefore, there will be two reaction. It will have a vertical and horizontal reaction since it is inclined. But if it is situated vertically, ang reaction lang niya is vertical. But if it is situated horizontally, then the reaction would only be horizontal. To solve for the B horizontal, we need to solve for B first. Okay, this is B. Okay, so this is B. We need to solve for B. So B vertical, B vertical is equivalent to the vertical component of the slope, which is 1 over the square root of 1 squared plus 2 squared. That is the square root of 5 over the square root of 5 times B. Okay? So we already have the B vertical. So substituting, B vertical is 16,998.96 is equivalent to 1 over the square root of 5 times B. Okay, so cross multiplying, we get B is equivalent to the square root of 5 times 16,998.96. So B is equivalent to square root of 5 times 16,998.96. That is equivalent to 38,000. Okay, that is in pounds. Do you think that this answer is correct? Okay, this answer is incorrect because isn't it that the slope of this incline is 2:1? And take note, B or let's say RB is perpendicular to the slope. Therefore, it will change the slope. So instead of 2 horizontal, it will now become 2 vertical and 1 horizontal. But same for the hypotenuse of the square root of 5. Therefore, instead of having this, we will have this. Okay? So, RB vertical is equivalent to the vertical component of the slope of RB. And that is 2 over the square root of 5 times RB. So substituting our B vertical is 16,998.96 is equivalent to 2 over the square root of 5 RB. So RB therefore is equivalent to 16,998.96 is equivalent to 2 over the square root of 5 alpha x. Shift solve. So RB is 19,005.42 pounds. Then from there I can now solve for R RH. Okay? So RH or yeah, RH BH rather. BH is equivalent to the horizontal component of the slope, which is 1 over the square root of 5 times RB. So B horizontal is equivalent to 1 over the square root of 5 times 19,005.42. And that is equivalent to 8,499.48 pounds. And that is B horizontal. Next would be the A horizontal. Okay, so for A horizontal, summation of forces along the x-axis is equivalent to 0. All forces that are pointing to the right should be positive. So what are those forces? So we have here the A horizontal and it is pointing to the right, so it is positive. Okay, next would be kita ba? Yeah. Next would be 1,500. So plus 1,580. The horizontal component is 1. So 1 over the square root of 10 plus 3,160 times the horizontal component of 1 of the slope over the hypotenuse of the slope, which is 10, plus 1,580 times the horizontal component of the slope, which is 1, over the hypotenuse of 10, square root of 10. Minus, we have here b horizontal, minus b horizontal, and that is 8,499.48 pounds, and that is equivalent to 0. Okay, so did we miss something? 1, 2, 3, 4, 5. None. So 1, 2, 3, 4, 5. We can now solve for a horizontal. A horizontal is equivalent to 6,500. So